Good morning dear students। ਅੱਜ ਅਸੀਂ 11th ਕਲਾਸ ਦੇ ਮੋਡਰਨਸ ਦੀ ਬੁੱਕ ਵਿੱਚੋਂ 5th ਚੈਪਟਰ ਕੰਪਲੈਕਸ ਨੰਬਰ ਦੇ ਐਕਸਰਸਾਈਜ਼ 5C ਬਾਰੇ ਪੜਾਂਗੇ, ਜਿਸ ਵਿੱਚ ਕੰਪਲੈਕਸ ਨੰਬਰ ਦੀ ਗ੍ਰਾਫਿਕਲ ਰਿਪਰੈਜ਼ੈਂਟੇਸ਼ਨ ਨੂੰ ਦਰਸਾਇਆ ਗਿਆ ਹੈ। ਐਜ਼ ਵੀ ਹੈਵ ਸਟੱਡੀਡ ਕਿ ਵਾਟ ਆਰ ਕੰਪਲੈਕਸ ਨੰਬਰਸ, ਤਾਂ ਅੱਜ ਅਸੀਂ ਉਹਨਾਂ ਦੀ ਜਿਓਮੈਟ੍ਰੀਕਲ ਰਿਪਰੈਜ਼ੈਂਟੇਸ਼ਨ ਪੜਾਂਗੇ। Let us take a complex number z is equal to x plus iota y. As we can see in this graph, here OM, this line represents x-axis. This is known as the real part of z. We can write it as real of z, and that is equals to x. And MP or PM, this vertical line is imaginary part of Z, so can written as IM of Z and is Y. So we can see here कि जो vertical line है that is imaginary part, and जो horizontal line है that is real part। ते जिहड़ा Z है this is called the magnitude. Let us denote it by equation 1, 2. So as in Pythagoras, by using Pythagoras theorem, OP square equals to OM square plus MP square, and OP square is denoted by Z, so Z square is equal to X square plus Y square. So mode of Z is equal to X square plus Y square is known as the magnitude, that is OP, magnitude OP of the complex number. Now if we represent the complex number in polar form, as we have written here, because Z was x plus iota y, let us take Z is equal to r cos theta and IR sin theta. Let us denote it by 3 and 4. Comparing equation 3 and 4, we get x is equal to r cos theta denoted by 5, y is equal to r sin theta, equation number 6. Now squaring and adding equation 5 and 6, we get x square plus y square is equal to r square cos square theta plus r square sin square theta. This will give us r square of cos square theta plus sin square theta. This is equal to 1 by the identity. So r square is this, so r is equal to x square plus y square, where r is OP, or we can say Z. So we can write it as r is equal to magnitude of Z, that is equal to x square plus y square square root. Now to find the amplitude or the argument of the complex number, let us divide equation 6 by equation 5. We can see here equation number 6 and 5. So this will become y upon x y upon x will be r sine theta divided by r cos theta. We can cancel r from both numerator and denominator. We are left with y upon x is equal to tan theta. If we take the inverse angle of tan theta, that will become tan inverse y upon x will become tan inverse of tan theta. So we got that is theta is equals to tan inverse y upon x, which is called the amplitude or the argument of z, and can be denoted by amp z or argument of z of the given complex number. So finally we got here the formula to calculate the magnitude and the argument of the complex number if z is the complex number x plus iota y. To find the magnitude of z, we can take the coefficients of real and the imaginary parts and the square root of that, and to calculate the argument and the amplitude of z, we can take the angle tan inverse of y upon x, that is coefficient of imaginary part divided by the coefficient of the real part. So by using these two formulas, we can find the magnitude and the amplitude of the complex number. Let us find the magnitude and amplitude of the complex number. Solution. Initially, as we know that iota cannot be in denominator, so we'll rationalize this. We got 1 plus iota whole square divided by, we are applying the algebraic identities here, 1 plus iota square plus 2 iota divided by 1 minus minus 1. So this is equal to 1 minus 1 plus 2 iota divided by 1 plus 1. This is equal to 1 positive negative cancelled, 2 iota by 2 is equal to iota. So we get the complex number 0 plus iota. Now as we know that this is x square plus y square, we can directly apply 0 square plus coefficient of iota is 1. So 1 square हमारे पास मिला 1 under the root, that is 1. And if we take the amplitude or the magnitude of z, that will be tan inverse y upon x. Y is 1 here and this, that is infinite. Tan infinite, that is equal to tan inverse of 90 degree. Now the other sum of this exercise are to represent the complex number in geometrical form in Argand's diagram. As we know that in complex number z is equal to 5 minus 3 iota, where real part of z is equal to 5 and imaginary part of z is equal to minus of 3, because real part of z lies on x-axis, or we can compare this equation or this complex number by x plus iota y, where x is equal to 5 and y is equal to minus 3. So we can take here the value of x is 5. This is 1 2 3 4 5, as we have studied in planes. in graph theory, and will go downwards because the value of y is negative here, 1, 2 and 3. So we got this point. After joining this is minus 3 and this is 5, so we get mod of z. Let us take this point as p. This is 5 comma minus 3, and in complex form we have already given here. So this is the representation of complex number in plane. Thank you.